I have an old graphics card here. This is an NVIDIA graphics card. It doesn't work. So we can have a play with that one. And I have another one. I think this one may work, although the fan's broken. And we have a couple more, which I'm pretty sure that's working, and probably this one's working as well. But they're not worth anything. And I have a few other things we can play with on this video as well. Motherboards, we can look at PCH. But first of all, let's just talk about reflow and reballing. So there's lots of information, and you've no doubt heard it, that you can put these things in an oven at 150 degrees centigrade or some similar temperature to that, and you can reflow the GPU. You take the heatsink and everything off first. So in fact, we'll do that with this board. Okay. So there is a graphics card. This is the GPU. This is a small one. Often they are much larger than that. So as I said, the myth goes that you stick this in the oven at about 150 degrees or 170 or something, and you reflow the GPU. By reflow, that would mean that you actually melt the solder that is sticking the GPU to the board, and when you cool it down, the solder solidifies and it repairs any broken connections. There's a couple of things I'll mention about this. This myth came from something that happened around 2009, 2010, a couple years around that era, and it's known as Bumpgate. So this was a problem with NVIDIA chips, and only NVIDIA chips. I'm not sure what this one actually is. Yes, it's an NVIDIA board, whereby you have, as you can see here, and I will zoom down on it, you have this piece in the middle. This is called the die, and this effectively contains all the billions of transistors. This is the device, and it sits on this green thing called the substrate, and this green thing on the underneath has the balls which connect it to the PCB. And if we have a look down there, I've just got the focus, you'll see it quite clearly. Yeah, stop wobbling. So you can see the balls. These are the BGA balls, and they're down there. What you can't see is that this glass looking thing here, this is the actual chip, if you like, that is stuck to the substrate. The green bit is also stuck down with tiny little solder balls or bumps, and these are much smaller. Now, the problem that NVIDIA had in the Bumpgate era was actually not to do with the balls we just looked at down there. It was to do with the connection between this die and the substrate. This is, as you can possibly see, it's stuck on with a kind of adhesive layer. And due to a manufacturing issue, this is the Bumpgate, around that time, 2009, 10, 11, the bumps under here were losing connection between here and the substrate. And it was to do with this, if you like, layer here that glues it down. It was to do with the rate of expansion and contraction, and that's why these chips were failing. They weren't failing because of problems in this layer, they were failing because of problems here. And this is where the myth of sticking it in the oven comes from. So with those chips, you could put this in the oven at about 150 degrees, and by effectively causing it to expand and flex in a certain way, you could get this to make contact again. But what you have to realise is that lead-free solder, which this is, doesn't melt till about 220, 230 degrees. So when you were doing this, there was no way that you were actually reflowing the chip. You weren't even melting the solder. Also, this problem that NVIDIA had during those years did not continue until later production. So chips of a later variety on more modern GPUs didn't have this problem. So while the problem did not persist, the myth did, and this is why people think that sticking it in the oven will fix the problem. They even think it will fix the problem on an ATI board, which is not even made by NVIDIA. It was NVIDIA who had the problem. So that is the history of this myth of reflowing, and when you do it, you're not actually even reflowing it, you're just heating it up. Okay, what we're actually going to have a look at in this video is reflowing and also reballing. So what's the difference? Well, with reflowing, you heat this up sufficiently to melt the solder balls between the BGA and the PCB. And if you do that, you can actually just touch this gently. You'll see it'll just move slightly, but the tension of the balls should actually keep it in place unless you move it too far. And if you have any soldered joints between the PCB and here, it's possible you will fix them. So you effectively put flux underneath it and then you heat it up to melt the solder. However, what you also need to take into consideration is that any bad joints under the balls have probably caused oxidization on the pads on the PCB, and you may not make a connection anyway, even if you melt the solder. This brings us to reballing. So reballing is the process of heating this up until the solder melts, taking the chip off the board, cleaning up the board, cleaning up the chip, replacing all the solder balls and putting it back on. That is reballing, okay? So don't let this confuse you. There's a lot of misinformation on the internet. That is the difference between the three methods. Reflowing can work. It just depends on how many bad connections. If it was caused by flexing of the board or flexing due to heating and cooling, it can work. Reballing is more likely to work if that was the cause of the original problem, but it requires more skill to do it, okay? So how are we going to practice with this? Well as this being a BGA chip, all the RAM, these are also BGA chips. So let's have a look first on this board. We'll just practice, and what we're going to do is to see if we can remove these RAM chips with a hot air gun. We'll also try with the hot air plus a preheater, see how well that works, and if we can do so without damaging the PCB or physically damaging the chip. I'm not saying we may not electrically damage the chip. And what temperature we need to get this board to actually do that. Yeah, let's practice with it. So first of all, let's just try just the hot air and see if we can remove any of these RAM chips. I'm going to do this using the hot air station. So this is a quick 861DW. It's quite a decent hot air station. I'm actually going to try using the temperature at 350 degrees. I also have programmed in 450, which I often use for unsoldering components, but we'll go at 350. The lower temperature you can do this at, the less likely you are to actually damage the chip itself. I have the airflow on full at 120. So let's see how well this can remove these RAM chips without a preheater. I'm going to use a thermocouple so we can see what temperature we need to get the board to actually do this. First of all, however, I'm going to put some flux on. So I'll just brush away the bit of dust from around here. Okay. And then I'll run some flux under the chip. The easiest way to do this is just put some flux around the edge. Okay. And then tilt the board like I have done, and we'll just warm it up from the side. And we should be able to get that flux to flow underneath it. I'll try adjusting the focus a little bit so you can see the board while I'm tilting it. Okay. Again, we'll put some more flux on here. And we'll get that to run underneath the chip. You can see it's actually disappeared under there. Now we just go to the next direction. So I need to do this just working around this chip. And there I'm sure you see it's gone underneath. turn it around again, and we'll do the same again. And normally I go around twice, so I do each side twice. Okay, same thing. That's flowed underneath it. Okay. Okay. Normally I would go around again, but I think there's probably plenty of flux on this. It's quite a small chip. To do this successfully, you want to make sure you keep well away from any capacitors. Those are probably far enough away. If they're closer than that, you should remove the capacitors before you start. Okay. And we'll just put a bit of Kapton tape to hold the thermocouple. So the thermocouple is near the chip. I'm just going to make sure it's not actually touching it. I've known on occasion these to slide as it comes off and actually solder the thermocouple to the pads underneath there, which is not what you want. Okay, so I'm just on a little metal plate here to protect the bench. I'll get a pair of tweezers and let's see if we can remove this RAM chip without dislodging these components here. You could, if you wish, put Kapton tape on, but I'm actually not going to. I'm effectively going to take the chip that way when it comes off. So let's see how hot we need to get this to actually remove this chip. Okay. This is quite difficult with a thermocouple because the hot air is blowing on it. So if we point this away from it, you see how rapidly it drops. So it's a bit difficult to get an actual reading. Yeah, you see what it's doing. This will now read more accurately what you have on the board. So you can see we're about 90 degrees, probably less. Okay. And you need to effectively get heat into the area, not just directly on the chip, okay? We need to try and get some heat into this general area. So just swirling this around, as you can see. Okay, what temperature do we have now? Well, it's actually not much warmer than it was before. 120 degrees maybe, 110, something like that, okay? So we'll keep heating. I'll probably need to get the board to about 240 degrees to successfully unsolder this. Let's see what we have now. Okay, you see it's actually nowhere near, okay? I mean, the thermocouples are up around 220 now. Well, actually, in fact, this chip is firmly attached, yeah? It's not that warm. Okay. About 180. I wouldn't normally keep taking the heat off like that. It's to show you guys what temperature we actually have in the board. Okay, and this is still firmly soldered. But you can see now we are definitely getting quite a bit warmer. Okay, let's see if we can go for it. So the chip still won't move. Okay, still not moving, look. Still not moving. Okay. So you can see I need to get a lot of heat into this to actually desolder this. Thermocouple's now picking up about 270. That still isn't unsoldered yet. What heat do we actually really have in this? Not enough, yeah? Let's see if we can actually do it with the hot air on 350. You can see how difficult it is to do this, guys. Now it's coming. You see it right now, yeah? You see it moving? Let's remove it. Okay. So we can do it, but it's not easy. Or at least it takes time. Okay, while the board is hot, let's have a look to see what we have. So you can see all the pads which were underneath the chip. I can actually clean these up with a bit of solder braid, and then we can see the board itself. The best time to do this is while the board is still quite hot, which it is. So what we'll do is we'll take the soldering iron, have it set to 380 BC3 tip, which I use, and we take some leaded solder. And what I'm going to do is I'm just going to melt solder onto the end of the iron, okay, and I formed like a ball on the end of there, and I'm now going to drag that across the actual pads and get a bit more. Okay, I'll move the thermocouple out of the way now. Okay, and I've just effectively just dragged that ball of solder around the pads. Yep, that's now removed the excess solder. What we're going to do now is to actually remove it completely. So we'll take fresh flux. We'll take a piece of solder braid. Okay, put the solder braid on here. We'll take the soldering iron and put a little bit of fresh leaded solder on it, just a small amount. Okay, like so. And then we're going to put this onto the braid. I'm not pushing, I'm just floating it around the actual board. Hopefully you can see that's picked up a lot of solder. It's actually flooded with solder now. Yeah, you can see it there, completely flooded with solder. A little bit more braid. If it gets too cool, you'll know because the braid will stick to the board. If that happens, don't try to move it with your soldering iron. Get the hot air back on and just heat the whole thing back up again. Okay, so a bit more braid. Also do it with small bits of braid cut like this, because if you use a long strip, it'll draw heat up it, and the braid won't get effectively hot on the end properly, then you may rip the pads off. Once more, tiny bit of solder, and we go over the pads again. Okay, same on the other side. The braid's moved right here. Just wait a moment while it heats up to temperature. Okay, I think we have a little bit of a bridge there somewhere. So that's how you effectively would remove one of these BGA chips. We would also then clean up the chip. So I'll show you this. And this is what you would need to do prior to reballing it. So once again, a bit of flux. I hope this doesn't move around too much. It's kind of stuck itself to the metal tray a little bit. Okay. Bit of fresh solder, a ball of solder, float it around. Okay. And the same trick with the braid and a bit more flux. So whenever you add braid, you always put a little bit more flux on top of the braid, and you always put a little bit of fresh solder on the end of the iron. Just a little touch, yeah. That's all it needs. To clean this up, bit of isopropyl alcohol, and probably a bit of kitchen roll as well. Just to stop it going everywhere. To clean the chip, it's easiest just to drop it into the isopropyl, let it swim around a little bit in there. Okay. The flux can get quite hard underneath it, a bit tough to remove. You need quite a stiff brush to do it, stiff toothbrush, something like that, if you don't have one like this one. Okay, so that is now clean. Now we will get the microscope. Okay, and here is our board. So you can see I managed to desolder that really quite well. There's a little bit of solder left on that one there, but we could soon clean that up with a little bit of flux and braid as we did before. All the pads are good. No damage to the solder mask. So that space would be ready to fit a new component or to reball the old one. So let's look at the chip as well that I removed. Here's the chip. Again, you can see that's nice and clean. That is ready for reballing. Okay. There's no bubbles in it or uneven parts of the substrate. That would be a sign you've got too much heat in. So that came off pretty well. Now let's try the same thing with a preheater, and we'll see if it is much easier to do it with that. I'm going to use a very cheap preheater because I like to be a cheapskate sometimes, although I do have an actual reballing station behind me. You may have seen it, but we can look at that as well. But I know a lot of you guys don't have that sort of equipment, so I'd really like to teach you to do it this way. Okay, so we'll remove another one of these using the preheater plus hot air, and then we can have a look at a working card. I'll see which ones of these are actually working, and we'll see if we can reflow the RAM or remove and replace the RAM, and will it still work afterwards. And if we can do that successfully, then we can move on to larger BGAs such as the GPU on the next video. So here's the same board. We'll remove this one and we'll do it exactly the same way we just did, but this time we're going to use a preheater. First of all though, I'm just going to add some flux. I'll just clean this dust off the board. You don't really want that getting mixed up with the flux and going down behind the chip particularly. Okay, so a nice line of flux up there, and then we let it run behind the chip. Okay. Okay, you can see it's disappearing, or most of it's disappearing behind the chip. Okay. We'll get some down there. I'll just put a little bit more, you can't really put too much. Okay. Just make sure it's going down behind it evenly. Okay, I'm happy with that. So now let's get the preheater. Here is my preheater. This is a CADA 853B. This is a hot air preheater. This is quite inexpensive and it's pretty good for working on these sort of jobs. I do intend to buy a much larger infrared preheater so we can experiment with that, but I don't have one at the moment and nobody sent me one to review. So I will buy one, but we'll have a go with this. So this is where the hot air comes up. We have a temperature setting here, but you take this with a pinch of salt. This is just hotter and cooler. The temperatures don't really mean anything particularly. And you'll notice when this is on, if I just switch it on, you see like the lamp glowing and then going off. Yeah. So it doesn't actually give like a variable heat, it just gives pulses of heat, and the wider and more often the pulses are, the hotter the PCB gets. A board like this, we can just put it directly onto here. I'll just put something under the front to stop it falling forwards, so the chip we want to remove is above the heater, okay? So we set this on here and just find something to prop it up with. This will actually do. Just a fold up old Jiffy bag on there. It's not going to get hot enough to set the cardboard on fire. So that's set quite nicely over there, the position. Okay guys, for some reason the recording stopped. I am changing this PC, I've built another one. So I've already removed that one, but I'll do it again so you guys can see how it is done. This is the one I've just removed, you can see it came from there, but I'll do this one. So I've positioned it again, just get the something to hold it level, and we'll do this again for your benefit. So I have the preheater switched off. You can see this is still a little bit warm from the previous time. I will actually add some flux under this chip. Move this one out of the way. Okay. Let's put some flux under this one. Same procedure as we did previously. Add some flux down the side of the chip. Tilt it slightly and let it run under. Okay. Next side. Flux. Under it goes. Flux. Under it goes. Okay, I might add just a little bit more. I'm fairly confident that's gone under the chip nicely, but you can't really add too much of this stuff. If you want to put more on, it's not a problem. Okay. Now let's get the preheater set up. Yeah, for the second time for me. This area of the board will be a bit warm now because I've been just putting flux under there. Let's put the thermocouple on. Yeah, you can see it's about 50 degrees. I have the thermocouple bent so it's actually touching the board, but I don't want it to slide under the chip. Okay, so this is cooled down to about 37 degrees. I had to do something for a moment there. So power on, heater on, and I've set the dial to 138, which is the first division. 158, sorry. That's a very accurate number for a very inaccurate machine. It's warming up, but it will not get to anything like 158 degrees. I'll just move the thermocouple slightly. I do not want that sliding under the chip. If it does, it'll probably solder itself to it. Just put it there where it's out of the way, okay? So it's warming up nicely. This will get quite smoky, or it can do. I'm happy with that. Now I just moved it, you noticed. It's not going to go anywhere now. It's just resting on something on the bench. We're up to about 70 degrees, so it's warming quite nicely. As I mentioned, this can get quite smoky, so I have, this is effectively is a fan off a heatsink, socket 775 with a cowling. So I'm just going to put that to one side, so it's effectively blowing the smoke away from me, but not close enough to cool it down, okay? 75, 76, so it sort of stopped there. I'm now going to turn the dial up to 196 and let it warm up again. And I want to get this up to about 120 degrees before we get the hot air going on it. Just gently, take your time, no rush. When that stops increasing, basically you can just turn it up a bit more. Yeah, it's pretty much stabilised now. Up to the next division, says 234. Just make sure it's centered pretty much over the heater. Okay. 93. It's heating quite nicely. That's going to push us up to around 100. And then again I'll go up. Set to about 250 or so now, and I'm above 100, okay? I'll now turn it up to the next setting, 272, and I hopefully get this to 120. You can see it's starting to bubble, but this is not desoldered yet, of course. Okay. But it's nice and warm. So we'll now get the hot air, and simultaneously I'll turn the preheater up to full, and we'll come in with the hot air. And this should unsolder much quicker than the other one did. Okay. Not doing yet. I think it's going to go very shortly. Yeah, there we have it. And there is our chip. Turn the preheater off, leave the cold air on a little while to cool it down, and then we can have a look. Here's the PCB. So I haven't actually cleaned this one. This is directly how the chip came off. You can see effectively the balls are still there. And if you look at the chip, there. So that came off really cleanly, to be quite honest. In fact, that came off very cleanly. You just see something move there, but it's pretty damn clean. That one is okay. In fact, that may even just be a little blob of flux. Yeah, I just felt it with my fingers. It's not hard like a solder ball. So that's how that one came off with the preheater. Again, I think you can see very much so the PCB is not warped or damaged. It came off nicely.